Hi, my name is Tyler Knudsen, and I am a geologist with the Utah Geological Survey here in Cedar City. Here at the mouth of Cedar Canyon, Triassic and Jurassic rock layers are tilted at an angle of about 45 to 55 degrees. Being sedimentary rocks, we know these rock layers were originally deposited in a flat or horizontal position. This is what geologists call the principle of original horizontality. So the big question here is, what happened to these rocks between the time they were originally deposited flat, which was about 200 million years ago, and their now current tilted position? The answer is plate tectonics. Here in Utah, we sit on the North American tectonic plate. About 100 million years ago, another tectonic plate sat off the western coast of North America and began to collide and push against the North American plate. This collision caused the crumpling and the thickening of Earth's crust in parts of western North America, including areas here near Cedar City. And it was during this collision and this mountain building event and crumpling of rocks that tilted these rock layers to the position that we see them today. As a result of this collision, crumpling and folding of rock layers, a massive mountain range formed that would have stretched through parts of western, central, and northern Utah. Here near Cedar City, we would have been at the eastern front or foot of this once massive mountain range that existed here. It's important to understand that the collision of these two tectonic plates and the folding of these rocks was not sudden or instantaneous like a car crash, like cars crumpling in a car crash. This process would have occurred over a period of millions of years and was very, very slow. In fact, the rate or speed that these two tectonic plates would have collided was only about an inch or two per year, which is about the same rate or speed that our fingernails grow, so very slowly. But over a period of many millions of years, that 1 or 2 inches per year adds up to more than 100 miles of crustal shortening that happened in parts of western North America. It's also important to understand that this plate collision and mountain building event ended here about 65 to 50 million years ago. And since that time, this massive mountain range that once existed here is largely eroded away, and we can no longer recognize it in today's landscape. And that these tilted layers that we see in Cedar Canyon today are basically the guts or the eroded core of this once great mountain range that existed here. So these east-tilted rock layers at the mouth of Cedar Canyon actually have a counterpart to the west that dip in the opposite direction or are inclined to the west. And if you could bring these rock layers together, they would form an arch or a fold that points upward. This is what geologists call an anticline fold. When originally horizontal or flat-lying rocks are compressed, they can either fold downwards, which we would call a syncline, or they can fold upwards, which we call an anticline. And based on the rock patterns we see here, we know that these folded rocks here are part of an anticline. And unfortunately, because of more recent faulting, namely on the Hurricane Fault, that western side of the fold has been faulted and downdropped and is now buried beneath Cedar Valley, and we can no longer see those rocks. So this fold in lower Cedar Canyon is a significant geologic structure here in this region. In fact, geologists have given this fold a name. We call it the Canary Anticline. And we call it the Canary Anticline because there are also very good exposures of this fold about 10 miles south of here near the small town of Canaryville. So in total, the Canary Anticline is at least 35 miles long and extends from near Tokerville in the St. George Basin all the way north to nearly to Fiddler's Canyon on the north part of Cedar City.